Hi and welcome to this screencast. My name is Michael Matson. I'm a principal tech marketing engineer at Hewlett Packard Enterprise. With me on the other side of the US, I have George Castilla. George, can you introduce yourself for the audience, please?
Hi, Michael. I'm George Castilla. I work as a software architect within the Nimble Storage Group here at HPE. Currently, I'm focusing on our CSI driver, as well as other container integration opportunities.
Awesome. So today we're going to talk about the HPE CSI driver for Kubernetes and the HPE Nimble Storage container storage provider that we just released as a public beta. So, George, can you tell us a little bit what the HPE CSI driver for Kubernetes is?
Yep. So our CSI driver is a little bit unique than some of the other CSI drivers out there. Rather than including Nimble or 3PAR specific implementations within our CSI implementation, we have chosen to create a spec called the Container Storage Provider. The intent of this is to separate the CSI specific intricacies of integrating with Kubernetes and host site components from the actual provisioning of storage and snapshotting of storage. So our aim has been to make it as simple as possible for both end users as well as any other vendor that might want to implement the CSP spec.
Wow, that sounds like a lot. So how will this help customers deploy stateful workloads on Kubernetes safely?
Well, so from a customer's perspective, they can rely on our driver to handle all of the minutia and complexity related to doing things like iSCSI or fiber channel rescans, creating file systems, creating mount points and bind mounts to the container workloads. From a storage vendor implementation perspective, all they have to worry about is implementing our spec. So they don't worry about the details of Kubernetes and or other container orchestrators doing what they need to do. The requests just come through. The CSI driver then translates those into CSP REST APIs and invokes the CSP. So an implementer, for example, such as 3PAR or Nimble, just has to write endpoints that create volumes, delete volumes, things that are specific to the attributes of a particular volume, such as performance policy and QoS limits, are just passed through, and the implementer is responsible for configuring those properties on the underlying volume. Very simple interface to use.
Oh wow, it sounds like you get a lot for free with this framework, which is pretty awesome. So anyone who wants to implement a CSP essentially just have to do a very light lifting to get that rolling. So since this is our initial beta, what CSI features and capabilities will we be able to support out of the gate? I mean, CSI have a lot of going on for itself, so what can we expect in the beta?
So our primary goal was to bring parity to our CSI driver that we've had in the past with our Flex Volume driver. As you know, Nimble Storage has been on the forefront of integrating with Docker and other container technologies as long ago as I can remember. I think 3-4 years we've been involved in the growth of that industry. And so what we've done is first bring parity with all of the features that we've had before. So things like performance policies, QoS limits that you might configure on a volume can be configured through the CSI driver as well. You just define it in your storage class, pass that down through, and the CSI driver will pass it through to the CSP implementation. Beyond that, though, there's a lot of other interesting things that the CSI spec has done, namely volume snapshots. So we have the ability now to create snapshots as well as to restore from snapshots. The resize operation or controller expansion is now possible through the CSI specification. Other features include raw block volume support, volume cloning. So volume cloning as well as inline ephemeral volumes have gone alpha in Kubernetes 1.15. And we're excited to say that we have an implementation, our CSI driver, that works with those too.
Oh wow, that's awesome. Yeah, I mean Kubernetes 1.15, literally almost just got released and introduced those new capabilities. And I'm just curious, like there's a lot going on that is already out there that you can kick the tires on. I'm just curious, what is the Kubernetes interest groups around storage working on at this point in time? And is there anything worth mentioning that is coming down the pipe?
Yeah, absolutely. There's tons of work happening. I think there's certainly continued interest around inline ephemeral volumes. That's probably going to go from alpha to beta pretty quickly as customer interest grows around that particular feature. But one that we're discussing regularly in the community is the concept of volume groups and volume group snapshots. Essentially, this feature lets you group volumes together for the purpose of creating crash-consistent snapshots on those groups of volumes. It maps to what other vendors might call consistency sets, for example. What's really interesting about the future of this is that not only can it apply to crash consistent snapshots, it can also apply to application consistent ones. So what that means is when it's time to create the snapshot, there'll be a set of pre-hooks that a customer or application can implement that essentially will freeze all of the containers that encompass an application. Then a volume group snapshot gets created. This gets offloaded to our CSI driver, which in turn will make the appropriate CSP call. And then once it completes successfully, there'll be a set of post hooks that will thaw the application. So you get this end-to-end disaster recovery configuration for either crash consistent or application consistent snapshots.
Oh, wow. Yeah, I personally can't wait to see that. That is something that we've been thinking about for a long time ourselves here, how you can capture that application state and do useful things with it. Yeah, I mean, that is just so cool. So, all right. Thank you so much for all your time, George. And I'm going to cut over to do a demo of our driver here and show you how things are being done, and let's get right to it. The HPE CSI driver for Kubernetes is available on GitHub. It has one main repository, and it's also accompanied with the deployment repository, which hosts the Helm charts and all the YAML declarations to get the driver running. I'm going to cut right down to the chase here and basically install this onto my Kubernetes cluster, 115 cluster I have running in my lab, and we're going to install it using Helm. I already configured my Helm repository pointing to the CO deployments GitHub repository I just showed you. I also have a values file that kind of points to my backend storage array that provides the credentials and so forth, and also where my HPE Nimble storage containers storage provider is running. So that's where the service name and port is referencing. I also don't want to create a storage class. A default storage class is by default installed if you installed it through Helm, but I'm going to create those manually to show you how that works. Gonna go deploy it here, I'm gonna do an install, and I'm gonna reference my values file. It takes a couple of seconds to pull down the images and start up the driver. There we go, it's up and running. We also installed a couple of CRDs, and some of the CRDs are part of the upstream community, like the volume snapshot class and volume snapshots and so forth. But we have an HPE Node Info CRD that will allow us to gather information about the nodes themselves where we install the driver. So we can see here that the driver is installed on my two compute nodes. The data that we can abstract from the node is like the IQN and the networks. And if this would be a fiber channel host, we would also be able to see the worldwide port names of that particular client. There's no storage classes installed. I'm going to create a bunch of storage classes here just to show you how it works. Here we have the HPE standard storage class that I'm going to create. I'm going to make this my default storage class. I also need to reference a bunch of secrets here for the different Kubernetes CSI sidecars. I'm also going to apply a few CSP specific parameters that are specific to Nimble, right? So you have the set a custom description on the volume. You want to limit the IOPS. You want to have a particular performance policy, protection template, and so on. And for this particular storage class, I want the end user to be able to override the IOPS limitation and the performance policy. We're also going to demonstrate volume expansion in this demo, so we need to set that on the storage class as well. I also have a storage class for the database that I'm going to deploy. The demo is basically deploying WordPress and doing some data management on those persistent volumes that will support the WordPress installation, right? So this will basically be the MariaDB database storage class that the volume will be provisioned from. So I'm going to boost the IOPS a little bit, tweak the performance policy, and so forth. Otherwise, it's roughly the same. The storage class parameters are CSP specific, right? So I'm just going to go here to the CSI Driver repository and show you the different parameters, right? So they're kind of grouped into different sections, like the common provisioning parameters, support all the legacy flex volume parameters that we had previously. We have some parameters to do inline volumes within the pod specification. I'm going to show you how that works later as well, and so forth. And also the cloning parameters have a separate section on that, and also the import parameters. And these parameters that are parameters you can either put in the storage class or allow as an override for your end user to set to a specific value. Right, so let's go back to the CLI here. So I'm going to create those two storage classes. And we can see that we have one default and one named HPE database. And the persistent volume claims I'm going to create, they're pretty vanilla and standard. I'm going to create one persistent volume claim for the MariaDB and going to reference the storage class name directly and create a volume of 16 gig. And then we have the volume for the WordPress application server. What I'm going to do is I'm going to create a 128 gig volume, and I'm also going to override certain values. So since we're mostly storing files in this volume, I'm going to apply the Windows file server performance policy, and I'm also going to set it to a fairly low IOPS of 5,000. All right, going to go create those two PVCs. All right, got immediately created and bound. So we have two persistent volumes. And what I'm going to do, I'm going to log into the HPE Nimble Storage array and show you that these volumes, they are actual volumes on the array itself. Okay, back to my CLI here. Now I'm going to create the WordPress application. It consists of two deployments and a front-end load balancer. So I'm just going to create those objects there and going to set up the application. I have a route set up here. I'm going to refresh this. There we go. And now we have WordPress running. We just need to create the credentials for the admin user and so forth and do some initial setup. Gonna log in. What I'm going to do is I'm going to write a blog post, create a title, going to upload a picture as well to make sure that we actually can store assets on the application server. Perfect. There we go. view posts, here's my content, right? So it's pretty standard, pretty vanilla. So the next thing I want to show you is how we can leverage a volume snapshot class to create snapshots directly using kubectl to provision the snapshot. So let's create the snapshot class, and then we can look at my volume snapshot declarations here, that we can basically reference a persistent volume claim and a snapshot class to create a snapshot in Kubernetes. And the same thing for the WordPress volumes, very similar. You just reference the PVC, and then we create those two snapshots. Right, snapshots created. What we now can do is we can list the volume snapshots in Kubernetes, but what I also want to do is to go out to the storage array and actually inspect the volumes, check the data protection tab, and we can now see that we have a snapshot on those volumes. And now what we can do is that we can reference that particular volume snapshot in a PVC with a data source specification. Right, so you specify which snapshot you want to use by name and what kind it is, and that will essentially create a new PVC based on that snapshot. So I create one for the database and one for the WordPress instance. We should see that those should be immediately bound, WordPress clone, MariaDB clone. And now I'm going to install a second instance. Basically, it's the same type of deployment in a different front end. And we can also see here on the array that we have two clones cloned from those two volumes. I also have a different route set up, WordPress clone address, where we will be able to access the cloned instance. So boom, there we go. And this is essentially just cloning one volume to another, and this is pretty simple stuff, but and we've been able to do this for a very long time. But what is unique here is that you can do everything from Kubernetes. You reference the snapshot name through Kubernetes and so forth. The end user doesn't need to know the physical snapshot name and so forth. So we can easily add some content here and see that the cloned instance is actually not affecting the production one. What I want to demonstrate next here is basically how you can use the CSI volume expansion feature. So in WordPress, I'm going to install a very simple plugin that will monitor your disk space, and this is just to get the number, how much free space we have, and after we increase the space, we'll be able to see an increase, right? So we can see now we're roughly at 128 gig of available disk space. Go back to my CLI and I edit the actual PVC, and I'm going to do this on the clone because we just want to test this capability. We don't want to affect our production instance. So I'm going to do the resize on my clone, and I install the plugin on my clone and all that, and I'm messing up my clone, so my production instance that I first deployed is not affected by this. So I'm just going to find the spec, resources, request storage. I'm just going to double that in size. And now that PVC is edited, I'll refresh this a couple of times here. This should go fairly quickly. All right, there we go. So now we have 256 gig of free space on our WordPress application instance. So it's very easy for users to do this operation. And we can also see on the array that obviously the volume has been resized. All right, I'm going to go ahead and delete my cloned instance and my cloned PVCs just to demonstrate that we're also able to delete those clones very seamlessly. I'm going to refresh this, and we're now back to 2 volumes. All right, the next thing I want to show you is how to leverage something called inline volumes. And the neat thing about the inline volumes is that they're completely ephemeral. So they only live for the duration of the pod. So one of the use cases here is basically how you can use like a scratch disk for a pod, leveraging external storage instead of consuming storage from the server that you would normally do for, like, if you're storing data inside your container itself. That could be very impractical for a number of reasons. Another powerful thing that this also allows us, that I'm going to show in a demo at a later date, is how we can leverage the inline construct to create clones of production data and run in your pod for the duration of the pod, and then essentially destroy the clone and its parent snapshot it created, right? So you can basically get a ephemeral instance of a production instance at that point in time, and it only lives for the duration of the pod. And that's very useful for CI/CD pipelines and other DevOps centric workflows where testing is very, very crucial and essential. So essentially the spec here is very simple. You specify the driver and some attributes. There are also a few mandatory attributes and so forth that you need to specify, and simply you create that pod inline. The application itself is very simple. It's a IO ping is a tool that kind of just checks for file system or block device connectivity and see how it works. And we can now see that we have a multipath device running there. And back on the array, we can now see that we have something called, and it's prefixed with the ephemeral keyword and then CSI and the unique handle that you get from Kubernetes for the UUID. And we have to hit Control-C here, and then we delete the inline example here, pod IO ping deleted, and then we do a refresh here, and we will see that the volume was automatically deleted, right? So it's very neat for scratch space type use cases. All right, so next up is how to leverage volume mode block. And this is a very neat construct where you simply specify in your PVC that you want the volume mode set to block. The default is always file system, right? So you will get a formatted file system on that block device. And setting it to block will basically allow an application to access the block device directly from inside a pod. So let's create that as a PVC, as any PVC. And then we can see in the actual pod here I want to create, you can see that I'm using the IO ping tool again and just pointing to the block device. And instead of specifying volume mounts, you specify volume devices. And that will basically allow you to point to a certain device path within the container. And then your reference is as any persistent volume claim, the block device. I'm going to create that. I'm going to just tail log that. Wait for it to come up. There we go. So now we can see that we have a block device of 32 gigs that we're currently pinging, and it's actually pointing to the device directly. When we ran IO ping in the previous example, you could see that it pointed to an XFS file system that was pointing to a multipath device that was actually being referenced from the host. And now we can see that the device is actually directly inside the container. And we can see on the array here that this is just like any other PVC. It doesn't have a file system, but at the end of the day, it's just a volume. All right, that's all for today. You've been watching the HPE CSI Driver for Kubernetes using the HPE Nimble Storage container storage provider. We will be back shortly with more content in this area as we close in on our generally available date later this fall. And until then, take care. Thank you. Goodbye.